Hello. Now we are going to talk about latch. So you know that latch is going to store one bit of information, and it is level triggered, and it is the asynchronous device. So latch, which is also called as transparent latch, since whatever input we are going to give, same input is going to available at the output also. So like suppose here we are going to write d equal to 0, then our output also going to come d equal to 0. And q dash, it is complementary, so it will come 1. So that we are going to see for the one by one input we are going to give, and we'll observe the how this d latch is going to work. So here we have enable. So that enable, again we have two concepts for this. One is called as active low enable. So active low enable means we are going to get the desired output when en is equal to 0. Another we have active high enable. So in the active high enable, we have en equal to 1, then we are going to get the desired output. So now since here we are taking the condition of the active high enable, so enable is 1 for us, and here D we are going to give input as the 0, bits are given here, so D is 0 here. And if you see that in this case we have 4 NAND gates are there. This is NAND gate 1, 2, 3, 4. So this NAND gates 3 and 4 are the cross coupled, where output is connected to the input of the another NAND gates. So operation of this latch again depends how these NAND gates are going to work. So in the NAND gates, we have concept that if any input is 0 here, then output will be 1. So on the basis of this, we are going to see the operation of the latch. Now since D is 0, so here that we have inverted output here. So for the NAND gate 2, this will become here 1. So now if you see that for the NAND gate 1, both inputs are here, that is 0 and 1. So when inputs are 0 and 1, so output of the NAND gate is 1. And for the NAND gate 2, inputs are 1, 1. Both inputs are 1. So here output will be 0. Now to the NAND gate 3, one input is 1 here that we have from the previous NAND gates. And for the NAND gate 4, we have one input that is the 0. Now from the NAND gate 2 table, we know that if any input is 0, we are sure that output is 1. So for which NAND gates you are sure that what will be the output? That is the NAND gate 4. Since your input is 0, so we are sure that this output Q dash is 1. Now this Q dash is given back here input to the NAND gate 3. So both inputs are 1, 1. So output of the NAND gate 3 is the 0. So now here what we are seeing that we are giving the input D equal to 0, and we are getting output also Q equal to 0. So that's why D latch is called as transparent latch. And here Q is equal to 0 and Q dash equal to 1. So this is the condition of reset. So that we see in the truth table also here. This is the active low. And so when En is 0, that whatever input is available at that D, that is not accepted by the gates. So there is the no change. What was the previous state, it will remain in the same state. Whether it was reset, it will remain in the reset. If it was set, it will remain in the set. So now we have given D equal to 0. So we saw that this latch is now in the reset state. Now we'll give the another inputs. On the basis of that, again, we are going to see what will be the operation, how this input and outputs are going to change. Now we are going to take D equal to 1. and we have concept of active high enable. So EN is always 1 here. So now inverter output is here 0. So that NAND gate 1 having one input as 1, another input is also 1 due to enable. So finally NAND gate 1 output is 0. To the NAND gate 2, one input is 1, another input is 0. So finally output of NAND gate 2 is 1. Now to the NAND gate 3, one input is 0. To the NAND gate 4, one input is 1. So from the NAND gate truth table, we know that if one input is 0 to the NAND gate, we are sure that output is going to be 1. We can predict the output. So here 0 is the one of the input to the NAND gate 3. So here output of the NAND gate 3 is 1. Now this 1 is given back here input to the NAND gate 4. So 1, 1, both are the inputs are 1 here. So NAND gate output is 0. So here we are getting Q dash as 0 and Q as 1. So this is the condition of set. Now latches or device are in the set state. And again, you can verify that D was 1 here and output is also Q is 1 here. So that's why D latch is called as the transparent latch. And here next state, if you want to write in terms of equation, so that we can write Qn plus 1 equal to D. So property of the transparent latch, here we have in case of D latch. And to understand the operation of D latch, we have operation of the how these NAND gates are going to behave. So only one concept you have to remember, that if any input is 0, then we are able to predict the output of the NAND gate, and that output is 1. Now if we try to compare D latch with SR latch, so if you see that in case of SR latch, here one input is S and here another input is R. There was no inverter. Now from the SR latch, we have converted into D latch. So for that purpose, if you see here, we are using the inverter and D is connected together. So one input D is given directly, and to the another NAND gates D is given through the inverter. So these are the discussion about D latch. If you have any inquiries, you can write in the comment section, and we can continue again another topics or latches, other things we are going to cover. Thank you.